So we'll talk about their improvements in MySQL 5.5 and 5.6. So MySQL 5.5 is our latest and greatest GA aka stable release, which was released about half a year ago in December. Oh, actually, December 2010, not 11. And we also released the corresponding Percona server as stable in April 2011. It's proven to be a rather stable release. In the first few months, what we've seen, we haven't seen as many problems from people upgrading the release. Right? I can say we have seen a few, some performance regression, something else, but it hasn't been nearly as bad as in case of 5.1 or 5.0. Now, MySQL 5.6, the first development milestone was released in April 2010 at Collaborate and MySQL User Conference. And there is also, in addition to that release, number of features available from labs, MySQL.com, the features which are not quite stable or complete, like, for example, memcache support. Now, what is important here is we shouldn't be kind of very excited and say, oh, you know, MySQL 5.6 is right around the corner. That is first development release, and if Oracle follows through on their plans, they are expecting to have a major release every 16 to 24 months, right? So we can count on how long that's going to take. So I would expect it still a year to 2 years before we would see MySQL 5.6 as stable. So what is in MySQL 5.5? I think the main, most important thing in MySQL 5.5 is better scalability. That was the main focus of that release, as I would put. There is also Performance Schema, which helps to get better transparency in what is going on inside of MySQL server, and again, help to optimize performance. There is improved Windows support. There are some replication improvements, signal resignal in stored procedures, and improved partitioning support. And I will talk about some of them in more details. When you look at performance and scalability improvements, there is a number of things. First of them would be log open. In MySQL, before MySQL 5.5, one of the giant bottlenecks on SQL level, which is not even touching any storage engine, or it would be probably any storage engine, was table cache. So there could be only one thread opening and closing tables at the same time, which could cause a lot of problems. And also there was a global linear search done for some operations. So if you have, let's say, large table cache and there are a lot of kind of free slots in that, it could be taking the time to find a slot to open the table. Both of those have been fixed in MySQL 5.5. There are a lot of small optimizations SQL level as well. There is like local alarm, which was used for could be bottleneck for active socket operation. It was replaced by setting the set timeout, socket timeouts on most operation systems which support those. We have a log thread count, which was very aggressively used for a whole bunch of operations, which was also removed. Log char set, that was used for a lot of work with complex escalations, again, removed. A lot of those logs, you probably may not have heard about them because they are rather workload specifics. But the thing with MySQL note of cases, well, if it sucks, it's like a big time, right? I mean, if it is a big problem, it is a big problem. Now, if you go to InnoDB optimizations, there also have been a lot of optimizations done. The logsys mutex was improved. I'm saying improved because that can be still a bottleneck for a lot of write-intensive workloads where a single log file, which InnoDB has, right, can still remain a bottleneck. But that was improved by changing to 2 separate mutexes instead of 1. Separate flash list mutex. That is another one. The flash list, there was a buffer pool mutex which was responsible for a whole bunch of operations, and now it was split a number of mutexes, and one of them is flash mutex. So in case there is a lot of flash operations going on, you can get better performance. Probably the biggest change, right, and the most, I would say, well-known in MySQL 5.5 and InnoDB world is multiple buffer pool instances. So even though I'm saying the buffer pool mutex was split into, let's say, flash mutex was kind of taken out of that, it still remains a very hot contention point. And the way it is improved is MySQL 5.5 allows you to set multiple buffer pools. When you enable multiple buffer pools, you will get their pages essentially placed to those buffer pool by hash. So you don't have any control like, oh, I want to have these tables go into buffer pool number 1 and those tables go into buffer pool number 2. It's kind of absolutely transparent. Your data is just going to be distributed to those buffer pools by hash. And those can help very significantly if you have contentions on the buffer pool. So what is 2 things which are important here? First of all is for certain workloads, there are given pages which remain hotspot, right? I know, let's say if you are having a lot of reads to a single row. In this case, you will continue having a hotspot because the single page will belong only to a single buffer pool, right? The second thing is if you're running MySQL 5.5 on multiple CPU system, you most likely want to set multiple buffer pools, but you have to be careful because there are a number of operations which become slower than you have multiple buffer pools, because kind of all buffer pools have to be, you know, scanned for some of them. So you want to try, and you don't want to get crazy, right? You don't want to say, hey, let me set to 256 buffer pools, because, well, that's probably is overkill. I would say anywhere from 4 to 16 buffer pools is where I see the sweet spot. Multiple rollback segments. So what is the rollback segments? Well, rollback segments is the area where InnoDB stores undo information. So it can roll back transactions, and it's also used for accessing the old versions of rows, right? If your transactions has to read something older than the current version. And it is both contention spot and its scalability limitation, right? How many of you have ever run into a problem if InnoDB doesn't allow more than number of concurrent transactions? Anybody has that? Yeah, of course. So the thing here is InnoDB would limit to up to 123 concurrent transactions because of which is how many kind of slots you can get in a single rollback segment. And actually, it is worse than that, because InnoDB will use separate rollback segments for insert and updates, right? Because when you're inserting records, like you don't have any previous version, right, to care about. So it's kind of can have a bit different format. And that means if your transaction is doing both inserts and updates, for example, if you're running insert and duplicate key update, that is a perfect kind of both insert and update kind of operation, then you are going to use 2 transaction slots per such operations, and you will be limited by 512 transactions, not by 128. Now you get 128 rollback segments, and so that problem pretty much goes away, both in terms of contention and in terms of a limit. What is interesting and why this is kind of very unusual change, that the old version of InnoDB actually can work with multiple rollback segments. We just wouldn't create that. So that is like almost unique situations of fair engineering where you can upgrade to MySQL 5.5 with InnoDB slash shutdown set to 0 upgrade, and then your MySQL 5.1 will be able to use multiple rollback segments right after they're created. Asynchronous I/O on Linux. This is also a rather important item. Before MySQL 5.5, InnoDB would use native asynchronous I/O, but only on Windows. Right? And on Linux, it was always simulated asynchronous I/O. So InnoDB will run a bunch of I/O threads, which will then perform synchronous I/O, which wasn't very efficient. Now, InnoDB can use native asynchronous I/O through libaio. It requires ODirect to work. And in this case, InnoDB will still use those helper threads, but each thread can now submit up to 256 I/O requests. So you can get a lot more outstanding requests with a lot fewer threads. What is also important in this case is this helps to push a burden from merging I/O requests from InnoDB back to kernel. And frankly, kernel and then hardware has a lot more clue about which I/Os are really sequential and which are not than InnoDB, which is another important point. As one of the things with asynchronous I/O, it's shown to make recovery faster. So crash recovery may be up to 1.5 times faster with MySQL 5.5. Change buffering. So InnoDB has a rather unique feature, I would say, called insert buffer, right, which allow to prevent random I/O caused by modifying or inserting rows into indexes by inserting them into some data structure called insert buffer. The problem with insert buffer was it was only used by inserts. Right? That means that your inserts can be fast, but then updates and deletes will be still rather slow. In MySQL 5.5, it was changed. It can now use insert buffer for delete mark, which is deletes, updates, and purge operations. So in this case, I point out what it kind of supports delete marks and purge, right? It is interesting note at the InnoDB architecture is what the update case is covered as well. Why? Because insert buffer only works for secondary indexes. And when you have a secondary indexes, InnoDB would not ever update the index record in place for multi-version purposes. It will always insert the new version for new index entry in the index, and then it will only purge unneeded versions during the purge operation. The performance gains, especially for large delete operations or large bulk update, can be pretty huge. It could be up to 40 times in some benchmarks, but that is more of a peak case. I would expect anywhere from 2, 3, maybe up to 10 times gains in real workloads. Separate purge thread. So in MySQL before 5.5, this purging operation, which is kind of removing old unneeded row and index entries, which are no more needed, was done by the same main thread, which had a lot of other duties. And this is why you could get that thread starving, kind of doing only purging operations, forgetting to do other stuff it has to do, and you could have kind of spikes in purging activity and really not very uniform MySQL performance. You could also have the history length, which is amount of unpurged transactions, growing, and MySQL unable to keep up. In MySQL 5.5, there is a dedicated purge thread, which you can enable by InnoDB purge thread, which takes care, right, of some of those problems by having multiple, having separate purge thread. It doesn't solve actually all problems, right? Sometimes you need more than one purge thread to really be able to keep up, but that's another story. Adaptive flashing. The adaptive flashing is not the new feature in MySQL 5.5. It was updated to deal with multiple buffer pool, and also this kind of constantly getting small tunings. This is really a pretty tricky problem. Like, how can we flash with dirty data so we don't kind of take too much bandwidth from disk subsystems, so we cannot serve things like foreground reads or have enough bandwidth to sync our transaction log, at the same time as avoid kind of running out of space in the log files and causing the database stall. And the best approach could be very different depending on the workload. So MySQL 5.5 can be a lot smoother on many workloads, right, avoiding database stalls, but I would say it's still not perfect, and I would say there are still going to be work done on this feature to get it better. So what about Windows? Well, on Windows, the biggest change is using native Windows API instead of going for POSIX, which raises a lot of limits and makes a lot of things more, a lot faster. One of the changes is, for example, using critical section for mutexes and like a native condition variables instead of POSIX. These are proved to be a lot faster. And let me kind of show you a couple of graphs. This is not my benchmark. This is from InnoDB blog, but I kind of, but it looks quite reasonable, right? So you can get to see what with high number of connections, things were just barely usable on Windows, and now it's a lot better, and especially I would say for read-write workload, where you can see there, like even those graphs look similar, you can see the scale is different, right? Which one goes up to 1024, which goes up just up to 256. So for read-write workload, the problems would happen with as low as 32 concurrent connections before MySQL 5.5. Another good question here is if MySQL 5.5 is always faster. Is it? Well, the answer, it's not. Especially, I would say, the single-thread workloads can be affected, because a lot of trade-offs in MySQL 5.5, they pointed to getting more scalability, right? For example, when we split one mutex into two, what do? Well, we do slow things down for single-thread workload because we add in the code, lock in a separate mutex, which wasn't there before, right? And there are a lot of changes like those when in MySQL 5.5, the trade-off was done to get better scalability for a little bit loss of speed in single-thread workloads. And I would expect there are also a number of changes which had some unintended sequences, and as in kind of pretty much any MySQL release on my memory, it takes like 6 months to a year to work out those like small regressions which can be easily fixed, right, which are not done by some architecture changes. Mark Callaghan from Facebook also reported some sysbench regressions. I'm not sure if I have fixed. Do you know, Harrison? Okay. So, but I would say there haven't been like huge regressions. I can tell, hey guys, if you are using this use case, don't use 5.5 because you will really regret it. So what are remaining issues when it comes to scalability, and in particular in InnoDB in MySQL 5.5? Per index read-write lock. That is where I would say the biggest issue for a lot of cases when you have one table which gets a lot of reads and write operations. For each index in MySQL in the table, when InnoDB is to do update, it has to set the, let's say, log, read-write log for doing updates in that index, which will prevent pretty much from any reads using that index. So that can be pretty bad. A lot of people don't really see this problem. If you are having many tables, right, so you don't have one table which gets a lot of contention, you wouldn't see this as a problem. If you're using, you can also use partition to work with this around. It works for some workloads. It doesn't do for other, right? If you're doing lookups for a lot of secondary keys, which are kind of cannot be partitioned easily, then you can lose a lot of CPU time by having large amount of partitions. Kernel mutex. That is kind of catch-it-all mutex for accessing a lot of internals in InnoDB. And that was kind of was not touched in InnoDB for a lot of time because that is kind of extremely complicated and it's used for so many things. But now work is on the way in MySQL 5.6 to deal with that mutex and have more fine-grained locking. Adaptive hash index. That is another big deal, right? In MySQL 5.5, we still have adaptive hash index, which can speed up access through indexes a lot, but it can also be a huge contention point. And in a lot of cases, we kind of have this kind of pretty bad choice, right? Well, do you want to remove adaptive hash index so we can get, let's say, half performance with low number of threads, or do we want to enable adaptive hash index and so things do not scale with many threads? Well, that is not a great choice to have. Finally, I would mention compressed tables. If you would look at any benchmark shown by Oracle and a lot of other parties, you wouldn't see anybody actually showing good scalability numbers with compressed tables. Well, because they're not there. I don't think compressed tables, since they were initially implemented, got any significant attention in terms of improving scalability. And I hope that will happen someday. Drop in table space with InnoDB file per table. This is another nasty one. If you're dropping the table with InnoDB file per table, it causes a table space drop, which requires to scan buffer pool or scan LRU, whatever you like to call it, and which can take a lot of time. The funny thing here is the larger you set a buffer pool, the slower this operation gets. And this is kind of like confused a lot of people. Oh, I'm upgrading to this box, you know, and I use 10x more memory. Why everything just started to crawl? Well, at least in MySQL 5.5, this operation doesn't stall everything because it's no more done under their table open log as it was in MySQL 5.1. Log mutex, I mentioned, that still causes contention, and group commit. The group commit is sort of like fixed, but only if you're not using completely durable setup. If you're using sync bin log equals to 1, right, and if you don't want to lose any transactions in binary log if power goes down, then in this case, you won't have a group commit working. Now, what do we have in Percona Server 5.5? What is different? Well, in Percona Server 5.5, it's bases a lot on the performance improvements made in Percona Server 5.1, right? So what we've done mainly right now is ported those changes to MySQL 5.5, did evaluation, and we have kind of seen some changes when similar changes were done by Oracle. We've seen you know, which approach would be better, where we have to stay or keep. We also have done MySQL multiple adaptive hash indexes. So same as MySQL allows to have 5.5 multiple buffer pool, we also allow to have multiple adaptive hash indexes. The trick here, though, is adaptive hash indexes the hash data by table, not by the page hash, right? So it only really helps if you have a lot of tables. Another important change that you can really see the difference in is what we have changed. So fast index creation, actually code used for adaptive hash index and alter table in a lot of cases. We as well changed MySQL dump utility to use fast index creation, because before that, you would have to use very special syntax sort of to benefit from adaptive index creation. And if you would use standard operations like you do MySQL dump and load stuff back, well, even if there is a fast index creation, it won't be used. Now, I should note even if you look at the performance server, there are problems to be solved, right? Don't be tricked by benchmarks people show you, including us, which says, oh, like, it scales to 48 cores, right, or whatever. There are, the answer remains, it depends, right? This is kind of very sort of relatively simple read-only workloads, right? What we're having here is a query which does large in clause select on the secondary key. And what I can see here is going from 1 to 32 threads, we get like just about 2.5x more performance, right, with a large number of threads for 5.1. And it's a lot better in 5.5. But if you really look at the number, it just sets x, right? That means, well, I can use only essentially it's like 6 cores, right? I can't really go to my, modern systems where I can get 12 cores, let's say, and 24 threads in 2-socket CPU, right? Not even speaking about 4-socket systems. MySQL 5.5 is Percona 0.5.5. Yeah, so that is one of the benchmarks, and frankly, one of the cases which we really focus on and pay attention on. This is on solid-state storage. And you can see what we both have better performance, as well as their adaptive checkpointing is more tuned in MySQL 5.5 to be solid-state storage friendly. So Percona 0 has a lot more kind of stable performance in this case. And you guys know what is kind of a spike at start? Why do we get to 30,000 transactions and then drop back below 20,000? Any ideas? Why do you have that spike at start? Come on. Harrison, save. Oh, okay. You can continue reading your emails. Okay. So what the deal here is when we just this spike, right? When we just start MySQL, it doesn't have to flush dirty pages, right? Because all pages were flushed and shut down. And it can just go without doing any data flushes up to a certain point when it used up maybe half the logs or maybe 75% of them. And then after that, it starts flushing them aggressively, right? So that is why we spike. And I want to illustrate that what this overhead of flashing dirty pages in background is actually a pretty big deal. So let's talk about 5.6. I will be a lot more brief about 5.6. Well, frankly, because we're having its development release, and this list will change, and I believe we'll get more information of what that means in practice, right? How much performance gains or other benefits which can gain from these things. There are optimizer improvements, such as index condition pull down and multi-range reads. I think a lot of those will help with NDB cluster especially, right? Because that is where being able to kind of batch access to storage engine is very helpful. Order by a limit. MySQL would not actually sort everything if you're only requesting 10 top rows. Then have a simple stuff. Persistent InnoDB statistics. And that stuff was actually already available in Percona server starting 5.1 plus, right? So Oracle used their own code. They didn't take it out, but I'm very happy to see what some of the things we've been doing kind of acknowledged for validity. And if you have seen, I mentioned the keynote in the morning today saying Percona server is like MySQL server future today. Well, that is because we get a lot of cool stuff first. Metrics table. This is another way to get stats in InnoDB. It's kind of similar to show status, but has more data and has some things like min, max, value of parameter for period of time, and such. And this is designed as a light way to get information in addition to performance schema. Why? Because performance schema can get rather a significant overhead if you enable it completely. Expose internal data dictionary. as system tables like systables, sysindexes. Again, we had that for a while. Buffer pool information tables. That's another one. It helps to understand what exactly is in my buffer pool, which tables or indexes are cached, and so on and so forth, which can be very valuable things to understand why you're getting cache hits for stuff you would expect. Oops, wrong button, right button. What else? Multiple purge threads. As I mentioned, getting their dedicated purge thread was just a first step, right? I mean, as it's kind of probably will be very natural, will make a lot of sense. When you have a lot of threads doing data updates and creating undo entries, one thread wouldn't be enough to clean those up, right? You can produce a lot more than you can consume. And that especially happens when you have like very disk bound workload and your undo space grows large enough, so this cleanup operation require a lot of I/O rather than can be done in memory. So again, we have some multiple purge threads coming in MySQL 5.6 or Percona 5.1. Even better in InnoDB scalability, especially work on kernel mutex is very important. One fun fact here is about InnoDB, and I'm not sure what Oracle is going to do about that, but I'm hearing what InnoDB is actually in 5.6 scales better than Oracle in some workloads. So which is kind of probably interesting. No SQL access from Memcache API. I might talk about that. I won't talk in more details. It's there. It's also there with a handler socket API if you want it today. There's also Memcache access to MySQL cluster NDB. It has its own and frankly very rich API for data access, but if your development team is most familiar with Memcache, that is a very good feature, right? Because NDB cluster is persistent. It's kind of you can has an after sharding in a sense, and so on and so forth. What else? Crash save slaves when using InnoDB. That is also very important for operational needs. So what happens in MySQL, right in slave right now, if you shut off a power? Well, you can get all kind of stuff like slave restarting from a wrong position, relay logs being corrupted, and all kind of other fun. We have done a number of changes in Percona server, so we can store slave position also in InnoDB log file. But in MySQL 5.6, you get this stuff in a lot more kind of natural and user-friendly way, which is very important to operate in MySQL on scale. Do you like this feature, Harrison? Yeah. Oh, you're still doing email? No. Okay. Good. We have it in R5 as well. What's that? I said it's in R5 as well. Oh, yeah, it's all in U5. But anyway, I think that's cool, right? Replication event checksums. That's also one of those replication things which people have been asking for, at least since replication was released. There is also improvement in row level replication. So MySQL is able to log less data. And especially in the case when you would, let's say, update non-blob column in the table which has a blob into that. Time delayed replication. You could do that with number of tools like slave delay from Modkit, but that is very nice to have it actually included in the server, so you can get time delayed slaves for disaster recovery needs. You can get a query text stored in row-based log, so you can actually understand from what real query those statements came from, right? Because sometimes if you're using complex things like multi-table updates, it may be very confusing to decrypt from which user-level query the row-level events came from. Remote bin log backup is also pretty cool, right? So that allows us to actually get the raw copy of a binary log on a separate server. So in case master crashes completely, you actually have a copy of binary log for point in time recovery or for catching up your slaves and stuff like that. Serial UUIDs, right? In this case, that is very helpful for running MySQL replication on a large scale because manually assigning server ID may be quite inconvenient. Multi-threaded slave, also known as parallel replication, also known as MySQL replication holy grail, right? Because in a lot of cases, we are limited by replication capacity. We can write a lot more on a master, right? But replication single thread, bad. And the more cores and the more kind of I/O capacity we can fit in the single box, the worse it becomes. In initial release, it will be per the database schema replication, but hopefully that will improve then. Improved performance schema, which has table level I/O, logical operations being tracked, like number of inserts, deletes, and so on in the table, same as like in Percona user stats or like Google, like Facebook patch before that. Table logs accounted to also statement information, like did that select used temporary tables and such stuff. Better partitioning. There is like number of things in partition, like explicitly selected partition for queries and some others. Pruning InnoDB internal dictionary cache. This is helpful, or let's say important, if you're running very large amount of tables per MySQL instance. Let's say 10,000, 100,000. Previously, InnoDB would just keep all those tables open, right? So once you access the table, it sticks in memory, and even if you don't access that table ever, it sticks out there and uses your valuable memory resources. That is no more, it's fixed. Another interesting thing here, which is also corresponds to partitioning support, is ability to export partitions or kind of like exchange partition and table, which is one of those kind of very powerful features of merge tables, which were lost in case with partition tables. But now it's back, right? So I can say, okay, I loaded my data from September. In this table now I can flip it and insert kind of in partition without all this actual insertion process, right? Pretty cool. Well, that's all for me, and I'm reminding you guys about our wonderful sponsors helping us to make this event a success. And I have about 5 minutes to take your questions if you have any. Any questions?
Yeah, does the parallel replication, the multi-threaded replication, can you tell us a little bit more about that? Does it work for statement-based or just RBR?
Well, so that is a RBR base as far as I know. And other questions? Yes. Well, this is the modification to the format, right? And frankly, I can tell you for a lot of the stuff I haven't looked in a lot of detail. So the point here is it would not have to log a full row, right? If I'm updating row on the table which has primary key, right? And let's say an increment counter by 1. So what I really need is just a primary key and before-after image for that given column, right? Not for a whole table, right? And that is, I mentioned, the most helpful in case of blobs, right? If you have like a counter table and you also have this 1 meg blob, it would be painful to include that in each event. Any other tables? Oh yeah. No, well, in this case, I mean, if you have a master and you have a bunch of slaves, right? Application to those different slaves is already parallel. So the question is making one slave parallel, right? And in this case, it would be able to use multiple threads applying data to different databases. Yes. No, in this case, it doesn't apply that, right? That simply means that you point your master to a given master, but the changes on the slave will be applied in parallel, right? When it's possible. And I would say this is kind of relatively early release, right? The multi-thread replication is kind of in the labs, right? It's not even in 5.6.2. So I would say, well, I would expect there would be a lot of things to fix it, make it work right. And what exactly we'll see in MySQL 5.6 release may be different, right? Maybe we'll be able to make it work in parallel in more cases, right? Or maybe we'll run into some problems.